Having a bulletproof umbrella is a nice fantasy. Have you ever wondered what it could be made of? To discuss that, let's see how materials behave when we compress them. A majority of the materials expand on all other sides because they have a positive Poisson's ratio. If there is a material with negative Poisson's ratio, then it would shrink on all sides when we compress it. Thereby, when the bullet hits, particles come closer together, resisting the load more effectively. Although nature does not have many such materials, fortunately, we can design structures to behave this way. Consider a hexagonal honeycomb pattern. When loaded, it expands, giving an effect of positive Poisson's ratio. When the system is modified, so it behaves as a material with negative Poisson's ratio. This is an example of how we can design the internal structure of materials for the behavior we want. These artificial structures are also fancily called as metamaterials. By now you would know that the behavior of metamaterials is primarily dependent on its geometry instead of material chemistry. This is what gives us, the structural engineer, freedom to design the internal structure for the behavior we want. However, there is an issue. Consider a metamaterial that is made for a particular behavior, say to resist the impact of a bullet. When the bullet hits, the geometry of the structure changes. With the change in the geometry, the properties get altered. So the question that I had on my first day of PhD is, can we design metamaterials to be independent of deformation? At first it appeared as if I was on a mission impossible, because by definition the properties of metamaterials depend on their geometry. Some night outs, coffee and everything crazy gave the eureka moment. A simple way that we found was to have two systems that behave opposite to each other. By combining them right, if we can cancel the effects against one another, then we have a metamaterial whose properties are independent of deformation. This solves the initial issue that we had raised. Until now, we have designed two such class of metamaterials with constant Poisson's ratio over large deformations. Now we are looking if there are better ways to achieve this. The sooner we get it, the sooner you get your bulletproof umbrella.